Okay, our last topic and our last module. So this one is kind of a different one, but it's a formula that once you know it, it's pretty easy to use. Okay, um, so I'm going to write the binomial formula first. Okay, if we have an expression that is of the form a plus b to the n, okay, and we wanted to completely expand it. It might take us a while, okay, but we can also use the binomial formula to do this. So there's a couple pieces to it. First of all, we have what's called n choose 0, okay. This is going to be like a coefficient, and then a to the n, b to the 0, plus n choose 1, a to the n minus 1, b to the 1, plus n choose 2, a to the n minus 2, b to the 2. Okay, and then we would continue doing this. So where the n choose something just keeps going up, okay, until we get to, well, here, I'll do one more. N choose 3, a to the n minus 3, b to the third, okay? And then what would eventually end with is n choose n, a to the 0, b to the n, okay? So you can see how that's different from the first term to the last term, okay? We do n choose 0, n choose 1, n choose 2, n choose 3, all the way until we get to n. The exponent on the a starts at n and works its way down to 0, and then the exponent on the b starts at 0 and works its way up to n, okay? Which means that right before this, we would have had n choose c to the n minus 1, a to the 1, b to the n minus 1, okay? And we could even do one more before that. We would have had n to the choose n minus 2, a to the 2, b to the n minus 2, okay? So it seems very confusing, okay? The other piece of it that you need is like, what the heck is that n choose 0, okay? Well, n choose r actually uses factorials, okay? It's n factorial over r factorial n minus r factorial, okay? And we learned about factorials in the previous one. So your question might be is, why would I ever want to use this long formula? Okay, well, the reason you would want to use this is if you are expanding to a really high power. Okay, so like, if we had 2 plus x squared, we're not going to use that binomial formula. Okay, it follows that structure there where it would work, but we don't want to have to use it. We can just square that. All right, but maybe if we had something as complex as, in the example that I'm looking at, 2p minus y to the 19th power, okay, do you really want to do 2p times y times 2p times y, and then multiply that by 2p, or 2p minus y, and then just keep multiplying that 19 times? You don't want to do that, okay? That would take forever. All right, we want to use the binomial formula there, okay, where a would be 2p, b would be negative y, and n would be 19. Okay, so what that would be then is n choose 0, so we would have 19 choose 0 times, if I go back up there, a to the n, b to the 0, so 2p to the 19 negative y to the 0, plus, and then we just follow this pattern, okay? And we're not going to do the whole thing, but then we have 19 choose 1, 2p to the 18, negative y to the 1. See, it's a lot easier once you actually have numbers to work with. So what you're going to see here, I'll use a little highlighter here, is that this is going to continue to count up along with that. And this is just going to continue to count down. Okay, so then we'll have 19 choose 2, 2p to the 17, negative y to the 2. Okay, and then we would go all the way to the end where we would end up with 19 choose 17, 2p to the, let's see here, that would be 2, negative y to the 17, 19 choose 18, 2p to the 1, negative y to the 18, plus 19 choose 19, 2p to the 0, negative y to the 19. Okay, so we skipped a whole bunch in the middle, but just showing you that basic pattern. Okay, and then we would simplify this. Okay, so again, if we have 19 choose 0, okay, that would be 19 factorial over 0 factorial, which 0 factorial is actually 1, over, here, this would be n is 19 and r is 0, over 19 factorial. So that's just 1. Okay. 19 choose 1 would be 19 factorial over 1 factorial times 19 minus 1 factorial, so 18 factorial. So we know that that would just be 19. Okay. 19 choose 2 would be 19 factorial over 2 factorial times 17 factorial, which we know that would be 19 times 18 over 2, which is 171. Okay, one thing that's kind of neat about this is that it repeats itself. Okay, so 19 choose 17 would also be 19 factorial over 17 factorial times 2 factorial. Okay, which is the same thing as 19 factorial over 2 factorial times 17 factorial that we just did. So this would be, again, 19 times 18 over 2, which is 171. Okay, 19 choose 18 would be 19 factorial over 1 factorial times 18 factorial, which is 19. And then 19 choose 19 would be 19 factorial over 19 factorial times 0 factorial, which is 1. Okay, so once you get halfway, they repeat themselves. Okay, so if we wanted to simplify what we had up there a little bit more, we could have 1 times 2p to the 19 times negative y to the 0 plus 19 times 2p to the 18 times negative y to the 1 plus 171 2p to the 17 negative y squared dot dot dot. Okay, and then when we pick it up, we would have 171 2p squared negative y to the 17 plus 19 2p negative y to the 18 plus 1 2p to the 0 negative y to the 19. Okay, and then we could simplify that even more. Okay, because the negative y to the 0 would just be 1. So I would have 2 to the 19 p to the 19. Okay, and then I would, keep going with that a little bit. Okay, so I'd have 19 times 2 to the 18, right? Because I can just split that up. 2p to the 18 is 2 to the 18 times p to the 18. So p to the 18 times negative y. Okay, and I can even take that negative out, make it, rather than doing times negative y, do a negative up front. Okay, so then the next one, I'd have 171 times 2 to the 17, p to the 17, y squared. Because negative y times negative y is just going to be positive. Okay, and then I could keep going. 171 times 2 squared, so I could even just do times 4, times p squared, times, I'm going to change that, y to the 17, and make the whole thing negative. Okay. And then I could keep going with that too. All right. Okay. So that's a basic idea. Okay. So we want to, it seems like, wow, that's a crazy formula to memorize. But if you work with the pattern, it's not so bad. Okay. And there's a lot of patterns going on here. So we can do an example. And what they're going to have you do is just find one term. Okay. So they're going to give you use your binomial formula to find the coefficient of the p to the 14, q to the 13 term in 3p plus q to the 17th power. Okay, so again, if I go back up to my whole binomial formula here, if I'm going to have, let's see here, 3p to some power, q to some power, and then that 17 choose something. Okay, so again, remember, these always add up to n for their powers. Okay, the a and the b. So if I see here, and it'd be the fourth there, sorry. Okay, so it's not a coincidence that 4 plus 13 is 17. Okay, so what that means is that my little subscript is going to be 17 choose 4. Okay, and then I'll have 3p to the 4th, and then q to the 13. Okay, so that's all I have to do. We'll do a couple examples here, but that's all they're going to do here. Okay, so all you need to do is figure out that since this is a 17, this is going to be a 17. And it really doesn't matter which one. You could do 17, choose 13 if you wanted to, because of the symmetry that I just showed you above. But we'll just do on the p, it's 4. So we're going to do 17, choose 4, and p to the 4th. And then on the q, it's going to be the 13. Okay. Now, why did I use 3p? Because it's 3p right here, and it's just q right here. Okay. All right, so we're going to simplify this. So 17 choose 4 is going to be 17 factorial over 4 factorial times 13 factorial. And again, it's not a coincidence that that 4 and the 13 add up to be 17. And then I'm going to do 3 to the 4th, and then I'll have my p to the 4th, q to the 13th. Okay, so it's a matter of simplifying now. So just like we knew before when we did our factorials, 17 factorial over 13 factorial is going to be 17 times 16 times 15 times 14 over 4 times 3 times 2 times 1. And then 3 to the 4th power, 3 times 3 times 3 times 3, that's 81. Okay, so that's the coefficient that we're looking for. Now we can just simplify it. And you're going to use your calculator. Okay, so 17 times 16 times 15 times 14 times 81 divided by 4 times 3 times 2. And so it is 192,780. And that would be the coefficient of that term in our expansion. Okay, we'll do another one. Oh, and I'm actually, give me 2 seconds. I gotta check. Someone's at my door. Just a second. Okay. And if this is kind of overwhelming for you, don't be shy. We can definitely do some lessons on this in class. Okay. But for our next one, we want the coefficient of u to the 16th, s to the 3rd, in the expansion of u plus 3s to the 19. Okay, so we're going to have 19 choose 16. And the 19, here, I'll use my little, the 19 comes from there. The 16 comes from there. Okay, and then we're going to do u to the 16, 3s to the 3rd. Okay, and the u comes from here. The 16 comes from the same place we got the other 16. The 3s, I hope this isn't getting too colorful for you, comes from here. And then the 3, I just ran out of colors, comes from, do we want to use a brown highlighter? Gross, let's do this one. The 3 comes from here. Okay, it's the same, I'm just trying to show you it's the same structure every time. Okay, so then when we do 19 choose 16, that's 19 factorial over 16 factorial and 3 factorial. Where'd the 3 come from? The fact that it has to add up to 16 to get to 19. Okay. So again, that'll be 19 factorial over 16 factorial, which is 19 times 18 times 17 over 3 times 2 times 1. Okay, so we'll have 19 times 18 times 17 over 3 times 2. I'm not going to write the 1 because we don't really need it. Okay, and then we would have u to the 16th, and then the 3 to the 3rd times s to the 3rd. Okay, to get us the coefficient there. And again, just use your calculator. Okay, 3 to the 3rd is 27, so we can do 19 times 18 times 17 divided by 6, and then times 27, and we get 26,163 is the coefficient. Okay, I'll do one more for you. We've got q to the 16z in q minus 3z to the 17. Okay, so again, we'll have 17, choose 16, q to the 16, negative 3z to the 1st. Okay, so we will have 17 factorial over 16 factorial times 1 factorial. We'll have negative 3 to the 1, and then we'll have the q to the 16z to the 1. Okay, so 17 factorial over 16 factorial is just going to be 17 times negative 3. This one's smaller numbers. Okay, so that will be negative 51, right? So the answer is negative 51. Okay, and that is it.